Okay, this is the Layer 3 VPN hub and spoke. The first thing I would say is that routes go one way and data goes the other. So as a route propagates through, data runs the other way. In this particular example, we're doing a hub and spoke. And the idea is that the spoke customer equipment will always go to the hub site before going to another spoke. And it allows you to have a central firewall and control all your traffic and basically control your policy from a central site, which is a preference from some customers. Now, although the data is going into the hub site and back out again, for the remainder of this explanation, I'm going to be taking the direction of the route flows, not the direction of the data. So just flip it if you want to know where the data is going. So we would like the routes coming out of the hub site and being advertised out of a VRF called hub. We have two VRFs here on the PE, and the first VRF is called hub, and it's going to be exporting out into internal BGP. And then the remote spoke PE will be bringing that hub export back in, and it'll be called a spoke import. And what we're looking for is the value here that we set on the way out. And of course, this is your route target. So your route target here, community value, we're now manipulating them for our hub and spoke. So the hub obviously has an import and an export. So the VRF export into internal BGP will set the community value hub. The import will be completely blocked, so very asynchronous. On the spoke side will do the opposite. It will be learning routes advertised from the spoke PEs. So the import, it will be looking for the value, community value of spoke, which of course is a target, community value target of spoke, and it will be importing them up here. So from BGP, from community spoke, accept. And on the way out, it won't be exporting anything. So hub exports, sets community target, spoke imports, receives community target. Now down on the PEs, it's slightly different. There's one VRF running here. It's going to be importing the target of hub so it can receive the routes. And it's going to be exporting the target of spoke so it can send the routes up into the central site. Okay, there's just a couple of other things we have to bear in mind here. Globally, we need to allow for loops. There's a couple of reasons why. We need to do this on the route reflector, because the route reflector that of course is in the middle of the internal BGP, it's going to be seeing the same routes coming and going, and without loops of 3 it's not going to work, because it needs to have those routes still valid when they're sent out, when they're bounced back, and of course the data has to go in and out. And then the second thing that we're going to put down here on the spoke routes is we're going to have AS override so that we can nullify any unusual ASs that may be set on the different customer CEs. And that allows us, it just replaces any unusual ASs with 54591, which is our AS that we're using here. Also, we mentioned that we would need to allow these loops on the route reflector, but of course also on the PEs, as you see here as well.